screen you should find one record.
Now it started recording. Yeah, we'll start now. Welcome everyone and welcome Mr. Arya. And it's nice to have you all. And I will put you all on mute. And if you want to speak in between, you can always open and speak. That is enabled. And as usual, I've gone through the presentation, so I know generally the flow. If you have any in-between questions, use the chat box to raise it with me and I will raise it with him in case it's relevant at that point of time and he has not answered it in the future slides. Sometimes what happens is, we ask a question, but later we realize that it's already being answered in the presentation. And as I said, it's a voluntary group. I keep sending the messages. If it's irritating, please tell me. I'll stop sending such, messages. And again, I want to mention that this is no attempt to preach anybody. This is only information sharing, and what you want to do with it, after that is completely your outlook. Now, if you like it, if you want to rephrase your thinking and thoughts and things like that, it is up to you. But if it is not up to this one, you are perfectly welcome to ignore this one. There is no attempt to preach and convert you from Vishwanath religion to Gavaskar religion or Shakespeare religion to Bernard Shaw religion, Newton religion to Einsteinian religion, nothing of that kind. So that you have to keep in mind, and the whole flow of presentation also will be like that only. And let me see if there are some invitees who have to be introduced since I had requested them. Where is the participants? Okay. And I have briefly introduced Dr. Mehrotra, who is professor with Bath University and JNU, and former Planning Commission member and World Bank co-author of SDG and Millennium Development Goals. Hopefully, he will agree to come on the show one of these days. It's nice. And as and when the other people join, I will maybe at the end or something, I'll request them to this one. That's just to introduce Mr. Arya. He is the author of these books. Only 3 of them I've listed. There are several more he has written on this chronology. One thing peculiar about him or different from the other historians of history, as you know, is narrative portion and the chronology portion. He concentrates on the chronology portion. One thing about him is he never trusts the other authors. He trusts always the epigraphs, inscriptions, tablets, plates, whatever carvings are found, because they are much less likely to be tampered with, both in terms of timing as well as in terms of the location, etc. Narratives, of course, anybody can put anything in the books which is published, and somebody quotes somebody quotes reverse quotes, and third person quotes, it becomes factual after that, and that's the way. And how much of history has been tampered with. The good thing about him is never uses any of those things as much as possible, other than to question any inconsistencies. That's this one. And of course, recent seminars given is day before yesterday. He was in Miranda House, Emergence of Mahajanapadas and Urbanization of India. And of course, his YouTubes have had, he doesn't host YouTube, maybe because he's also the Joint Secretary in Defense Ministry. So I think maybe there are some organization rules preventing him. But some of his other friends who have hosted have seen 2.8 million hits of his various videos. And he's also going to address a World Forum on 20th February, where Dan Winter from US and then Fernandez from Spain and he are going to address on the origin of languages. And of course, a few days back, he had sent me one critic of his from a Brazilian professor, written in Portuguese language, which presents some rhetorical criticism of his books. And based on which, as I said, you quote me, I'll quote you, and the third person quotes, and it becomes a fact. Some Christian missionaries have taken source from that and started attacking him, plus some US universities. I said, that's the best thing that could happen, to advertise yourself. So it only means that you have arrived in the scene. So that's the way things are. And that's how much I've got by way of introduction. And I now leave it to Mr. Arya. In fact, one of the things is, whenever you discuss with these kinds of things, why study and waste our time? So what? So what happens if Pythagoras' theorem is renamed as Bodhayana or something? Pythagoras' theorem is Pythagoras' theorem. How does it matter? This is the kind of criticisms which normally come up, and let's hold this question till the end, because some of these questions are answered in the presentation. And of course, the famous this one is, why only 5 grahas and navagrahas? What happened to the other 4? Did they even not calculate this other 5 grahas? Why have sun and moon become grahas when you know that they are not planets? These are the kind of rhetorical questions that you face. And let's wait till the end, till he finishes the presentation. Some of them will become clearer. After that, we'll take it up for answering. Mr. Arya, it's you.
Good evening. Good evening to all. Thank you, Kumar Swamiji, for introduction. I think, can I share my presentation? Because I think you are not able to run the presentation. The same.
Rajagopal also joined. He is a famous TV personality. Almost every day is there on the TV. But
thank you, Rajagopalji, and today. Today, let us discuss the India's scientific heritage and contributions. When I'm talking about, I'm not going to claim that we are having much more advanced sciences or scientific achievement more than the modern world, not so. But what I'm going to present it, what actually we have contributed to the world. But before understanding the India's contributions and India's scientific heritage, we need to know.
Hey, Mr. Arya, 1 minute. Mr. Arya, you can unmute yourself. Mr. Arya, you can unmute yourself.
Yes. Yeah. Now I'm audible?
Yeah.
Yes. So before going to the India's discussing on the India's scientific heritage and contributions, let us first go through what is actually our antiquity and what is the timeline of our Indian astronomers and mathematicians. Today, I'll mostly focus on the India's heritage of mathematics and astronomy. Though we have contributed a lot in even Ayurveda, metallurgy, even chemistry, various other sciences also. But today, I'll just focus on only the mathematics and astronomy. Before doing so, what is actually our traditional timeline? According to the traditional history, our pre-Siddhantic astronomy, what actually the difference between Siddhantic and pre-Siddhantic is, Siddhantic astronomy, actually they have incorporated the planetary motions also, and even followed the Jovian cycle of 12 years to find out the reconciling the lunisolar calendar, because lunar year, solar year has to be reconciled in a lunisolar calendar. So that's why they, instead of only focusing on the moon's motion and the sun's motion, they also incorporated the Jupiter orbital period also to reconcile the lunisolar calendar. So that is actually the beginning of the Siddhantic astronomy. According to the tradition, this Suryasiddhanta is the actually ushered in the Siddhantic astronomy tradition. So that Suryasiddhanta was written by Mayasura at the end of 28 Krita Yuga. Now, how to date the Suryasiddhanta? This is the one issue. So what actually I have done, I have gone through the Suryasiddhanta, and there is one shloka. It actually mentions that at the end of Krita Yuga, when Mayasura was living, he actually observed one perfect conjunction. And Sun was in the beginning, I mean, it's actually in the first degree of the Aries, and all planets were in conjunction within the 26 degrees. Any conjunction within the 30 degrees, because the one Rashi or one zodiac sign is almost 30 degrees. Anything less than 30 degrees is considered as a rare conjunction. So if you see this, I'll just show you the simulation. You can simulate on any astronomical software using the JPL horizons, because you have to use the NASA's very latest the time correction, because moon's movement and others, even gravitational forces also affect the planetary motions and the moon motion also. So this is the exact date is 22nd February 6778 BCE. And what I am saying that I have actually simulated up to 15,000 years from today to backwards. So almost 13,000 BC. This is the only date possible. And same conjunction has been referred in Persian astronomy, even the Greek astronomy. So this was observed, personally observed, because this can't be calculated backwards. So if anybody says that Indians have calculated backwards, it is utter nonsense, because otherwise we have to say that the ancient Indians know the algorithm of the JPL horizon, what has been developed by NASA, and using the so many modern computing power also. So this was actually the personal observation by the Mayasura, and he used this as an epoch and wrote the Suryasiddhanta. And when Suryasiddhanta transferred to the West, Persians took over it. And because he was an Asura, and Persians also migrated Asuras from India, so they started following it. This is how the Zoroastrianism turned into the kind of a solar worshipping community. And when the solar worshippers, the Persians, migrated towards the East and Eastern Europe, and when they have introduced this, then the Suryasiddhanta actually theologically transformed into a Mithraism. So the origin of the Mithraism in the West is also somewhere this Suryasiddhanta astronomy was behind the evolution of the Mithraism. And in the 7th millennium BCE, the new year used to commence somewhere in the winter solstice. This was the reason why a pre-Christian Roman tradition is that the Mithra god was born on winter solstice. They used to celebrate winter solstice as the birthday of Mithra. Later, the same birthday has been hijacked by the Christians, and they claim that the Jesus was born somewhere at the winter solstice. So this actually, I'll just skip. This is actually how why I made that you have to understand how the yugas have been evolved. As per my research, pre-Siddhantic astronomy, there was only 5-year yuga and 20-year Chatur yuga. Later, when Siddhantic astronomy was evolved, somewhere 6777 BCE, the yuga length has been increased to 1200 because they wanted a 12-year cycle. They were following the 12-year cycle, so they needed a yuga having the multiples of 12. So that's why they introduced 12 into 100, 1200-year cycle. And they wanted a bigger yuga because accurate calculations of astronomical, you can say planetary motions or calendrical calculations. But after the somewhere after 1200 years, they have even increased 1200 to 12,000 years, and then they come out of a kind of a differential duration. Then later, just before the Mahabharata war, the yuga has been increased to 4,32,000 years, and they just multiplied 1200 by 360. Why they have increased it? For having the accurate calculation, because in a year we have not exactly 365 days, 365.25. It's not actually 25. It is actually a fraction. So when you are calculating the fractions, so you needed a big numbers to have an accuracy. This was the reason why Indian astronomers continuously increasing the length of the yugas, and then finally they settled around 4,32,000 years. And then for the Chatur Yuga, 43,20,000 years. After Mahabharata war, slowly Indian historians also started believing that probably this is our historical timelines, but that was not our historical timeline. So we have to differentiate between how the yuga, the concept of yuga and Chaturyuga have been evolved. Based on the Suryasiddhanta evidence as well as the evolution of the yuga cycles, I came up with the chronology. It actually started the 7th Manvantara, that actually what we call it Vaivasvata Manvantara, that became around 7322 BC. Then it was 5-year, 20-year Chaturyuga cycles up to 6782, and the 20th Chaturyuga was 6782 to 677. This was the period when Mayasura wrote Suryasiddhanta. Thereafter, Treta Yuga had 1200, Dwapara Yuga had 2400 years. Since just before Mahabharata, our Yuga cycles have been increased to 4,32,000 years. This is the reason why Kali Yuga is still continuing even after 5,200 years. So this is the timeline I have prescribed in my book, based on the archaeoastronomical evidence before Mahabharata. After Mahabharata, I have used entire epigraphic evidence and inscriptional evidence as well as the literary evidence, and based on that, I have reconciled the entire Indian chronology. So I'm just giving that our Vedic era will go back to somewhere 11,000 BCE, more than 13,000 years before. It's not just 1500 BCE, what is being taught in the universities and in the world academia today. So now in this time, this is our antiquity. Based on this antiquity, what actually we have contributed, what are the discoveries Indians discovered for the first time. So those things we will discuss today. So let us see how the large numbers, because generally we have been taught that Aryabhatta discovered 0, but this is utter nonsense, because Aryabhatta, prior to Aryabhatta, also our 0 and decimal system existed. So somewhere during the Rigvedic period itself, we have invented the 0 as well as the decimal system. Yajurveda refers to a number up to 10 to the power 12. It means after 1 you put the 12 zeros. So these numbers, and in Yajurveda actually calculates with as a decimal system. So decimal system existed during the Yajurveda Rigveda period, and that was the period around 11,000 BC. Thereafter Ramayana, a number is given up to 10 to the power 62. And in Mahabharata, it is actually given 10 to the power 52. These are large numbers, are not possible without having a 0 and the decimal system, and even place value system also. So both these concepts have been evolved very early Vedic period itself. Then very later period, the Jain literature. Actually, the Jains even actually they used infinitesimals and infinity. Though philosophically they have explained the infinity, but they have actually used infinitesimals. So the one infinitesimal in the Jain literature goes to around 10 to the power 194. So such a large, even gigantic numbers. Even one very interesting story in the Lalita Vistara. Actually, Lalita Vistara is a Buddhist text in which when Buddha was still Prince Siddhartha, so a guru actually put him into a test saying that, okay, you tell me what are the large number. So then Buddha starts counting and he goes back to 10 to the power 421. So I don't know, even today, modern astronomy, probably they may be using such gigantic numbers. But Indians actually used, even just beginning of this so-called common era, just 2000 years before Lalita Vistara, this gives a very large number up to 10 to the power 421. So India has a very robust system of mathematics since Vedic era, and 0 and as well as the place value decimal system existed since Vedic era. So this was the strength behind our scientific, because mathematics is the basic science for the evolution of various other physical sciences. Numerous multiplication methods existed in India, like Gomutrika, Khanda, Bheda, Ishta, Kapata, Sandhi. I'm not going into details because Vedic mathematics books are available and many people are aware of certain methodologies. And these these were practiced by Indians since ancient times. Aryabhatta was the first person who gave the square roots, the methodologies for calculating the square root, cube root methods. This is the Kapata Sandhi. If you can see, both ways you can, it is a one multiplication method. And this was very popular even in the West also. Now, the arithmetic, how we have used the fractions, even Rigveda used fractions up to 1 by 16, 1 by 12, 1 by 8. And composite fractions also, there was the use of composite fractions in the post-Rigvedic era. And Bhagavati Sutra, it is the Jain text. It gives us, it actually calculates what is the size of an atom. So it gives up to 1.3 into 7. Actually, this is this size comes it may be coincidence, but it is actually equal to a carbon atom. So the size given in Bhagavati Sutra. And Lalita Vistara, the same test, the Guru asked the Siddhartha, okay, you have you gave the details of the large numbers, then you give us the the negative number. So that time he mentioned that a Paramanu is equal to 70th trillionth of a meter.
Mr. Arya, Mr. Mehrotra has asked you to slow down the delivery speed. If you can
okay. No, because there were many slides, so I thought let me rush through, because these are all just I'm mentioning that because all are aware, all are certainly you might have studied the mathematics, so I need not to explain.
My request was only that,
okay,
you know, there's so much info that you are giving us.
Yes.
It's not the math concepts, it's the the info is very dense. It's very dense.
Yes. Oh, thank you. Okay, I'll just this actually in the Lalita Vistara, when they started calculating that in the negative numbers, then he goes back to the 70th trillionth of a meter. So the kind of mathematics practiced during the Buddhist period was it is a very, very advanced mathematics in India. And a smallest unit of a time calculated in India is Truti, that is actually 1 divided by 33,750. So if you see, and even inverse divisor method was given in Indian text, even reduction to common denominator, and even calculation of square root of fractions. So such very complicated mathematics was practiced in ancient India. Now, the Bodhayana, we all know that he gave the Pythagoras theorem, but I'm just giving you another thing where how he has calculated a square root of 2. And he has to be dated somewhere 6500 BC. Modern textbooks, somewhere they just roughly give 800 BC without any chronology, because they don't have any chronology beyond Buddha. That's why they put everything, even Shatapada, Brahmana, Veda, everything they put around 800 or something. They don't go beyond 800. And prior to that, they said that some way Vedas were written between 1500 to 800 BC. That's why any Sanskrit text, they will date only up to 800 BC maximum. That's why they dated Bodhayana. So the way he gave the methodology, how to arrive the square root of 2. So this is the way what he gave in the top portion, what I mentioned. This is actually 577 by 408. This is actually the accurate up to the 0.5 decimal. But when you expand the same method, then it will give you around 11-digit accuracy. So such accurate methodology, method of a square root given by Bodhayana. And there is a Bakshali manuscript, because I'm now discussing the square root formulas. So this manuscript found in Pakistan, somewhere closer, near to Lahore, around 1870 or 1880, 150 years back. And this manuscript is written on Bhojapatra, and it is actually a homework or a note of a particular mathematician of very ancient period. Somewhere he has to be dated 100 CE as per my chronology. And presently, this manuscript is in the Oxford University, and they have carbon dated it. It goes to 200, 300, but they don't date this not beyond 700 AD. I don't know why, even though carbon dated. They think that some old leaves have been used by somebody living in 700 AD. Just because there is a chronological error of 660 year, what I have mentioned in my book, because there was the ancient Shaka era and the later Shaka era, both have been considered one epoch. Due to that, there is a chronological error of 660 years in our Shaka era related chronological timeline. So in this one, the Bakshali manuscript has given a square root formula to arrive the non-square number. So there are I just found at least 5 such calculations, and the accuracy is up to 5 decimal, 8 decimal places, 9, and even 11 decimal places. So I don't know, even somebody can calculate so accurately without using the computer even today. So that may be the challenge to the modern mathematicians. Certain arithmetic discoveries that Mahavira, he was the first person who says that real square root of a negative number does not exist. So this needs a very in-depth understanding of the mathematics. That is the Mahavira. He lived around 700 or 600 AD. And Brahmagupta, he says that every positive number has 2 square roots. And same Brahmagupta, he says that quadratic equation has 2 roots. And Mahavira was the first person who gave the Niruddha. Niruddha is actually LCM method. So I don't know why in our school times, when we were in the schools, we studied the mathematics books, we always found mention of only Western mathematicians or their names only. We never found any Indian mathematician names at all. This is actually the government job to ensure that what in the based on the context, they should mention that what actually ancient Indians have contributed much before the world even started. West actually started using decimal system somewhere 14th century or 15th century. Prior to that, they had no idea of zero also. And rule of indices, even concept of logarithm, actually Jain mathematicians invented or discovered this concept of logarithms. But modern days, we only credited John Napier. But at least 700, 800 years before John Napier's, Indians used the logarithms. This is actually a Matra Meru. It is Pingala. Pingalacharya, he was the author of Chanda Shastra. It is very interesting. Indians, Indian music is actually mathematically, I can say, the first, they used mathematical concepts in the music. So the permutation combinations, they use this method. This is called a Pingala's triangle, I want, because modern textbooks, it is they give that credit to Pascal, a French mathematician, but actually at least many thousands of years before, because Pingala has to be dated around 7000 BC. Pingalacharya, before Mahabharata era, Pingalacharya existed. So he wrote a Chanda Shastra, and he gives a method this, and he also applied the binomial coefficients to arrive this one. And it is simply, this is first you type 1, you start from the top, and then you write 1, 1. Then what you do, you just add 1, 1 is 2, then you 1, 1. Then again 1, 2 is 3, and 2, 1 is 3. This is how you will be actually expanding this Matra Meru, and then arriving the permutation combinations. And we all know the Fibonacci sequence. But same Fibonacci, he was a Florentine merchant and a son of a very affluent merchant. And when his father was doing a business in Algeria, that time Fibonacci traveled from Florentine, from Italy to Algeria. And there he studied Indian mathematics there in Algeria. This is the reason what he wrote. You can just read. We all give the credit to Fibonacci, but actually he's giving the credit to India. He says that comparing to modus indorum, everything else is a mistake. He's saying that the Indian method of mathematics is the only thing, is the best. Every other methods are actually wrong. So Fibonacci learned this sequence of numbers from Indian text, or those translated into Arabic. Probably Algeria, he may have studied Arabic text or translated into Arabic later. This is the time when it was the period of Crusaders also. They learned the Arabic and then they translated the Arabic text into Latin. So that's why the algorithm is actually the one Al-Khwarizmi. Al-Khwarizmi, a Persian astronomer who was working in Baghdad, he translated Indian mathematics into one book, and same book has been translated into Italy and came to an algorithm. This algorithm word is just a Latin translation of Al-Khwarizmi. Similarly, the same Al-Khwarizmi wrote a book, Al-Jabr wa Al-Muqabla. So that Al-Jabr, when the book has been translated into Latin, came to be known as algebra. So these two words, algebra and algorithm, in the West actually have origin from the Arab, and Arab astronomers and mathematicians translated and even learned the mathematics astronomy from Indian astronomers. There was a Khalifa in Baghdad. He invited Indian mathematicians. This is how there are more than, I have listed in my book, more than 20 Indian texts have been translated into Arabic or Persian language. So the so-called Arabic numbers, the West knew the mathematics and the numbers are, they called it Arabic numbers. Actually, those Arabic numbers were Indian numerals. This is geometry. This is well-known theorem, roughly used in Taittiriya Samhita, Shatapatha Brahmana also, but exact the theorem given by Bodhayana. So that's why this Pythagoras theorem has to be named as the Bodhayana theorem. The Shulba Sutras. These Shulba Sutras actually they used to measure the sites to construct the Yajnavedis. For that purpose, they used the Shulba, means the thread. Even just few, even probably even today also, and actually when the masons, when they start constructing a wall or other, they use a thread to, similar the thread was used. So that way Shulba means a thread, Sutra means rules, how to use this to measure. So this is how actually our mathematician solved the algebraic problem geometrically. So this is how our Indian algebra started evolving. Then Pythagoras triples, Taittiriya Samhita have many references of some triples, and Shulba Sutras have numerous triples. So at least these triples have to be mentioned, either Taittiriya triples or Shulba Sutra triples, not Pythagorean triples, because we have we use these triples at least 7,000-8,000 before the Pythagoras. Then this is very interesting. I'll just show you the history of pi value, how Indians started calculating the approximation of pi. Rigveda has a value of around 3, roughly, because a pi value is given around 3. And Shatapatha Brahmana, it gives 339 divided by 108 is equal to 3.14, accurate up to 2 digits. Shulba Sutra, because they use the thread and for the only constructional geometry, they never gone for such accuracy. So they have different values, sometimes 3.125, 3.16, and sometimes 3.088. And Suryasiddhanta used very accurate 4-digit accurate value, 3.1416. Aryabhatta also used the same, because in astronomy, this was good enough for them. So they used the same approximation of pi. And Jain literature, in the Jain literature, they used square root of 10 because they wanted to have a multiples of 10. So This was the reason they preferred using the square root of 10 as the pi value. Veerasena, he was one more great Indian Jain mathematician. He gave value 355 divided by 113. So it goes up to 3.14159. And then Madhava, he calculated up to 11 decimal places, 3.141596535898. Then Shankara Varma, he lived around 1774, is the Kerala mathematician. His value, what he calculated is 17 decimal places for accuracy. And there is one shloka, Gopi Bhagya Madhuvrata. This shloka gives the value up to 31 decimal places. I don't know, even without using the computer, even today any mathematician can calculate such accurate values. So just I'll show you this is the shloka. That Shadratnamala is the text written by Shankara Varma. He gave this the value of pi up to 17 decimal, and this is the shloka Gopi Bhagya Madhuvrata Shungisho Dadhi Sandigha Khalajivita Khatava Gala Halava Sandhara. So when you just based on this is actually this is called Katapayadi notation. If you translate that into the numbers, then this is the value. This is correct up to 31 decimal places. Shadratnamala is exactly dated around 1839 AD. This shloka, nobody knows who wrote when this was, but this shloka has been quoted by Bharati Krishna Tirtha in his book. So, but even 1839, we could calculate up to 17 decimal places. Then the irrationality of pi, because Indians always, whenever they calculated the approximation of pi, they just said that this is very asanna, very near. They never said that it is an exact value. So it appears that Indians knew the irrationality of pi. So Manava, he also says very close, simply asanna word they use means a very close approximation. Similarly, Aryabhatta, Bhaskara also say the pi is irrational and transcendental. And one thing what generally modern textbooks teach us that Lambert and these guys have actually discovered the irrationality pi just 300 years before. But Nilakantha, who lived around 1475 AD, at least 200 years before this Lambert. So what he says, if you can, what he said exactly, if the diameter is measured using a particular unit of measurement, then the circumference cannot be measured by the same unit of measurement. Similarly, if the circumference is measured using a particular unit of measurement, then the diameter cannot be measured by the same unit of measurement. Therefore, it is impossible to measure the circumference and the diameter by the same unit. This is nothing but irrationality. Since it has been written in Sanskrit shloka or Sanskrit text, so modern historians don't want to take it that you don't have any proofs. I don't know. Only if you write in English, then only you have a proofs. Otherwise, you don't have a proofs. This is nonsense. And even Brahmagupta, somewhere 600, he gives cyclic quadrilaters, the methodology, the formula. So actually, we must give the credit to our mathematicians. They have done actually wonders in that period when actually we were looking for very accurate astronomical values. This was the reason mathematics evolved much advanced stage. Parameshwara, he gave a formula for finding the circumradius of a cyclic quadrilater, but the modern textbooks give a credit to Lulier, somewhere 1782. Polygons, Bhaskaracharya calculated the sites, and the accuracy is very close that even modern values and Bhaskara's values, it's hardly any difference. Algebra, It was actually India was what I indicated during the Shulba Sutra period. They a constructional geometry. So for that constructional, they demonstrated algebraic truth geometrically. This is how we started discovering the algebra. And Indians worked on integral solutions of indeterminate equations since Shulba Sutra era. And the Bakshali Manuscript, it has linear equation with many unknowns and quadratic equations. Even indeterminate equations have been solved somewhere 2000 years before. This is the one method. What I'm saying, generally we have been taught that Aryabhatta lived somewhere 499 AD. It is totally wrong. The dating is absolutely incorrect. Aryabhatta lived somewhere beginning of the after Mahabharata era. So he gave a general method for finding an integral solution of indeterminate equations of first order. And he mentioned this method as the Kuttaka. It is very, that same Kuttaka method is called today as extended Euclidean algorithm. But it was at least a few 2,500 years before Euclid. This method was invented by Indians. Even so-called Diophantine equations must be named as Aryabhatiya equations, because Aryabhatta solved much before the lifetime of Diophantine. Brahmagupta gave very interesting one equation, and that is called today as the Pell's equation. And he gave a general formula for integral solution of indeterminate equation of second order. And he came up, he even gave kind of an algorithm which is called Samasa Bhavana. And this is the algorithm. So the Brahmagupta was one of the greatest mathematicians. He worked on very complex indeterminate equations of second order. And for arriving this, Jayadeva and Bhaskara, they actually invented a very novel method for finding the complete solution of indetermination equation of second order, and they called it a Chakravala method. This Chakravala method is much simpler and shorter method than the modern Euler-Lagrange method. Trigonometry, it's originated during the Shulba Sutra period, but Suryasiddhanta introduced half shorts in trigonometry, and actually the Suryasiddhanta introduced the spherical trigonometry. So if I just explained you in the beginning of my talk, the Suryasiddhanta has to be dated around 6778 BCE, almost 8,800 years before. But we teach our children that Hipparchus was the father of trigonometry. The Hipparchus and Mayasura lived at least 8,000 years before Hipparchus. So the real father of trigonometry was Mayasura, not Hipparchus. So Bhaskara invented a simple algebraic formula for approximating of sine and cosine values. We actually we started using these things since 8,800 years before. Somewhere 6,000, 7th millennium onwards, Indians practiced spherical trigonometry in Indian astronomy. And one great mathematician is Madhava. He born in Sangama Grama in Kerala. And this guy actually invented the real calculus. But we say that Newton was the father of calculus. But at least 300, 400 years before Newton, Madhava Sangramagrama, there is a Dr. C.K. Raju. He was the first person who said that the Jesuit missionaries in Kerala, they took the knowledge of Indian mathematics to, or Kerala mathematics to Europe. And then the scientists of Europe, they got this knowledge, and then they presented into European notation. This is how especially calculus, there are clear evidences that the knowledge was transmitted from Kerala to Europe. But the European mathematician, they claimed that they were the inventors of these methods. And numerous infinite series, infinite sine, cosine function, infinite tangent function, inverse tangent, pi, and these are actually, in modern times, we know as the Taylor series, Grigori, Leibniz, Euler, but all these things were invented by Madhava. It is one, on what basis why Indians practice such complex mathematics is because there was always a challenge to the Indian astronomers to predict exact time of eclipse. The solar or lunar eclipse, predicting the exact time of the eclipse, they actually went up to calculus because the motion of the moon is not so constant. It's little erratic due to gravitational forces. That's why what they do, you just observe the moon at the same time, then find out the motion, and then you predict it. For this purpose, ancient Indian mathematicians developed the concept of calculus, and that is actually the highest, the most advanced mathematics, what Indian astronomers and mathematicians practiced those days. So that's why calculus originated in India. Aryabhatta was the first who used the exponential function in his differential equation of the near instantaneous motion. That was the Sanskrit, it was called Tatkalika Gati. And Manjula, he was also a great mathematician. He invented the formula of differential calculus. Then Nilakantha, Jayadeva, Madhava, Bhaskara, they all worked on integral calculus. So much before Newton, Indians actually applied this calculus in the Indian astronomy. Bhaskara's theorem, what modern textbooks say as it's a Rolle's theorem, it was actually Bhaskaracharya who invented this theorem. And even Kerala Math Parameshwara gave an excellent version of mean value theorem. This is how now at the end, what I want to say that there are numerous theorems, what actually the discovery of such these discoveries have been attributed to many European astronomers or mathematicians. Actually, these were discovered much prior to the even the European Renaissance, or even before the Greek. The modern historians, what they say, Indian scientific heritage is not more than 2000 years. When Alexander came to India, so many Greek astronomers and mathematicians came to India. This is how India got knowledge of mathematics and astronomy from Greek sources, but it is totally incorrect. Indians mastered these sciences much before even the birth of Hellenistic astronomy or the Greeks. In a way, if we correct our chronology, it is actually the migration of Indians from east to west. The Aryan migration never existed. It is actually Indians migrated towards the Anatolia, Greece, and East Europe. This is how Indian knowledge transferred to westwards as well as the eastwards. So I just listed 30 ancient Indian discoveries, which genuinely the Indians were the Indians invented these theories, like Taittiriya triples, what we call it Pythagorean triple. Pythagoras theorem has to be Bodhayana theorem. Heron's formula, it is already used in Shulba Sutras, therefore it should be named as Shulba Sutra. And Bacchus-Naur form of notation, what in our computers, it is Panini used it around 1600 BCE, if we date correctly him. And Pascal triangle was actually Pingala Varahamihira triangle. Fibonacci sequence must be named as the Pingala Virahanka sequence. And even Hemachandra, they have used this sequence of numbers. And George Cantor theory, what infinity, concept of infinity, it is actually Jain. Okay, Cantor gave it more an advanced theory, but yes, we should give the the Jain and Cantor theory, at least we should give the credit to the Jain mathematicians also. And logarithms, not John Napier's, it is the Veerasena who was the inventor of the logarithm. Extended Euclidean algorithm should be named as Aryabhatta algorithm, and the Wilson theorem should be named as Bhaskara's theorem. And I just discussed you, Pell's equation was actually Brahmagupta he used. That's why the Brahmagupta equation, Brahmagupta should be attributed the invention of this equation. And George Cantor's theory of sets, and Veerasena was the person who used the theory of sets. And Newton-Gauss interpolation formula, actually Govinda Swami of Kerala mathematician, he used this formula at least 1,000 years before Newton and Gauss. And Mahavira's formula, then again Newton-Stirling interpolation, it is actually Brahmagupta. Then Sridhara's formula, what formula we are using for solving quadratic equations, it was given by Sridhara. Pati Ganita, a book written by Sridhara. And the Rolle's theorem, Bhaskaracharya theorem, then Fermat's factorization method was actually Narayana Pandit. He was the person who invented the method of factorization method. And Newton power series should be named as Madhava series. And Madhava invented numerous, all Taylor, Grigori, Leibniz series, Euler, all should be attributed to Madhava. He was the first person to invent those series, that infinite series. And the planetary model, actually Nilakantha invented this planetary model before the Tycho Brahe, but we credit Tycho Brahe as the inventor of the planetary model, and that was presented by Nilakantha at least 100 years before Tycho Brahe. So even Hipparchus, we call it him as the father of trigonometry, but at least 8,000 years before Hipparchus, it was Mayasura who invented the spherical trigonometry, or a very advanced trigonometry. And Diophantine equations to be named as Aryabhatta equations. If you see, we have Indians calculated. Generally, I have seen some French mathematician used to just mock about Indian mathematics. Indians only invented a zero. So he wanted to say that there is a zero contribution, he wanted to say, in the mathematics. But Indians contributed a lot, starting from Vedic era to up to Madhava. We have developed very, very advanced mathematics. So up to calculus, it's not just zero. So much advanced. We actually, ancient Indians did wonders in the mathematics and astronomy period, astronomy sciences. So we should claim our genuine discoveries, that we were the inventors, because this heritage will inspire the young minds. And it's not just, you are just reading the Western names in your text. So generally we are glamorizing the West in the young minds. So they're just looking for a jobs in the West or somewhere. That is the only way to progress in the modern world, but that's not correct. As a nation, as a descendants of a great heritage, we should teach our children that so much we have contributed to the world. This was the reason why Bharat was a Vishwaguru. It's not just we are boosting that Vishwaguru. It was really a Vishwaguru. They taught the basic sciences like mathematics and astronomy. Probably this such in-depth knowledge of mathematics and astronomy, what we have contributed to the world, probably or perhaps that led to the evolution of modern physical sciences. So thank you for giving me opportunity, and I thank all the audience, and if any questions, we can take it up.